Hey everybody, Risk Mr. Thrive and Survive, July 2nd, 2018. This is going to be a little bit of a different video. I'm going to talk about Miami International Airport, right here where my cursor is. This is Google Earth I'm showing. And we're going to measure a distance down across the water here into Cuba. We're going to go south of Havana, and we're going to zoom in here, this little curve right here. We're going to go over to here. That's 265 miles to this point right here. Actually, we're going to look at something that's going to be relevant about 270 miles, but let's just look. You know what? Let's just use 270. You're going to see that that's valid. We could use 260 if we needed to. But the distance from Miami Airport down to this point here, southwest of Havana, about 265 miles. Let's use that one, 265 miles. And 265 miles. I want you to notice here that we are going from land, looking over land, then we're looking over more land right here, then we're looking over water, then we're hitting land again down to here. Now, what I want to point out here is weather radar. No Cuban area is tied into the National Weather Service weather radar that we see broadcast, and that's going to be important. The fact that we're going from land to water to land to water to land again, and then eventually you'll see even the water down here, this little bay area here, is going to come into play. We're going to talk about weather radar and radar in general, and how there's a problem if the Earth is a ball and radar. Now, there is a problem that globe earthers have, or I'm not talking about current day globe earthers, but when radar was invented prior to World War II or during World War II, it was pretty quickly recognized that you could see farther than what the globe calculations would say. See, radar is pretty much a line of sight type of deal. And when you could see, like when I was in the Navy, you could see ships on radar 60, 70 miles away. They'd still blip. How is that possible on a curve? Because they'd be over the curve. Well, of course, they came up with some kind of BS that there's magical properties in water, and radar can somehow bend around the curve a little bit anyway. But, you know, if there's a problem, the globe earthers would all of a sudden invent and say, well, you know, radar can see around the curve from San Francisco to Hawaii, if need be. The excuses are just amazing. But let's take a look at this. 265 miles, that's what we're going to use, and we'll go from there. Now we're going to look at the control tower, which is the tallest building at the airport. Let's say the weather radar is on top of that building. I don't believe it is, but let's just give it to them. The tip of that building is 320 feet tall. And what about the airport itself above sea level? It's less than 10 feet above sea level. So 10 feet plus 320, 330 feet is the highest the weather radar would be there. So using that information, let's go here. Now we come to the Metacrap website, and the reason why I call it that, because if you believe refraction is causing things to rise and fall, you're actually not ignoring a theory, you're ignoring a law about refraction. When you don't have a change in medium, you don't have refraction. And when you don't have an angle of incidence and the horizon always rises to your eye level, so there's no angle of incidence, it breaks both parts of the law, which states how you get anything refracted. So in this case, we're talking about radar. We're not talking about visuals, so we don't have to get into refraction. But remember, 265 miles away is our target, and this will make sense shortly. The 330 feet, that's where we're saying the weather radar is. In fact, why don't we give it 500 feet? How about that? Okay. What's the distance to the horizon then? 27.38 miles. We're trying to look 265 miles out. And according to this, 27 miles, we hit the horizon. And remember, Anytime radar hits land, it doesn't have the so-called magical advantage that it has over water. It loses that advantage. You have a 2.22 miles of earth bulge in between you and the target. 2.2 miles. And you have 7.12 miles hidden. Now let's get a look at that visually. Here we go. Here's where the weather radar is. Here's the surface level. Here's our thing, our destination, 265 miles away in Cuba, well hidden by the earth, well hidden. Now, what we're going to be talking about is weather radar. Now, how far off the surface does weather radar look to report rain? Believe it or not, it looks, generally speaking, no more than 100 feet off the ground. Why? Because when you have anything higher than that, it's going to get returns from the water that is condensed and floating above the earth in clouds. You don't want weather radar to indicate clouds when you're looking for precipitation. You want it to actually measure precipitation. Precipitation falls. They're going to be looking generally from the surface up to 50 feet really, but let's give it again, let's give it more. 100 feet up in the air. So if you have, let's say, cloud-to-cloud rain going on, generally speaking, radar isn't going to pick it up because it's not looking above 100 feet in the air. Hopefully all that makes sense. Now let's get to some photos of a hurricane we had last September and take some looks at those pictures. So let's take a look at some of those pictures. Okay, I just took this off my phone. September 10th, this was last year, 2017. And let's zoom in a little bit on this and take a look what's going on. Remember, Cuba doesn't report radar. Everything, here's MIA here. You see this MIA up here near where my cursor is? That's Miami International Airport. Miami is the only reporting station. It's the only radar picking this hurricane up. Here's the center of the hurricane. Remember, Miami is over land. It goes over water. There's another swath of land here that it's going over. Radar right there should lose all of its advantage. Right there. Then we go over the Gulf of Mexico. We hit Cuba, where it once again should lose all of its advantage. We cross Cuba. Here's that little corner I was talking about, southwest of Havana. You see it's picking up 100 feet or less off the ground rain in this little corner here, 265 miles away under, what was it, 2.2, the bulge of the earth is 2.2 miles high here. How is it picking this up 100 feet off the ground? Let's take a look at something else. This is the exact same thing taken at the same time, except this is cloud cover. Just want to show you. Here's Miami up here, Miami International Airport, looking over land, hits water, looks over land again, hits land again, and picks up water over here. Just wanted to show you that so you can see what we're looking at. Just like on the first part of this video where we were showing the line going down, radar looks in a straight line and it shoots and it rotates 360 degrees. That's how you get weather radar images. Here's one more picture, and just to illustrate the point, this was taken at a slightly different time. We don't have the rain quite as far down here. The only reason why the weather radar can see this at all is because there's gaps in the mountains in Cuba. Cuba is a very mountainous place, and radar just simply cannot see through mountains. I grew up in the mid-Atlantic area, in Maryland in particular. There are mountains in the western part of the state. When rain and snow was heading from due west to east, we couldn't see it on radar a lot of times, except for little specks here and there in between mountain peaks is where radar could shoot through and see it. But it was most definitely raining and snowing out in the western part of the state. You could see that on the weather observations, the different stations that will report. So what we have here is an impossibility if the Earth is a globe. Let's go back and look at this again. Here you've got 7.12 miles, which should be hidden just from the distance alone. It drops 8.8 miles Radar, again, is looking for from the surface to 100 feet. That's it. There should be a 2.2 mile bulge right in the middle between the two that's hiding anything that's happening in Cuba. Let's go back to this right here. Now we can see hopefully what I was talking about. You have Miami, it's going, radar moves at 360 degrees, 1 degree at a time, taking pictures and coming back. What we have is an impossibility with the globe. This middle dot right here should be 2.2 miles higher than this area right here, and 2.2 miles higher than this area right here. How is weather radar seeing 100 feet off the ground or less down to the surface rain down in this area? Absolute impossibility on a curved Earth. It's just impossible. Again, once you hit land, radar loses its advantage. It becomes line of sight. Look it up. I worked with it. I studied it. I had to know it. And it's BS over water anyway. They just need a way to say, hey, why are we seeing ships so far out? Radar's got a limited range. Line of sight, they say it can bend a little over water, a little. But see, now with the optics we have, we can prove even that's BS, because we can physically see the ship 60 miles away if we have a good enough optics and a clear enough sky and clear enough weather. So here we go. We have radar picking up rain, passing over land, water, land, water, land. So many times it lost its advantage. Looking 100 feet off the ground from something 350 feet. I put in 500 feet. Remember, I gave, as usual, every benefit of the doubt to the globe. Another bust. This is only possible on a flat Earth. And again, the only radar that can spot this from the National Weather Service is coming out of Miami. There are no other connected radars to that. You can see it all the time. Every time there's something in the Gulf that comes through here, it always gets cut off at the very limit of the range that the radar has. In fact, the radar could probably go way out here and show you what's going on. It's not that powerful, because if it was, you'd be frying up everything around it. You can only add too much power to a radar before the radiation would just kill everything in the vicinity. That's what the limit is of radar. Radar could actually go forever, in my opinion, straight. As long as you have line of sight, nothing blocking the sight, you could see it. Or if there was, let's say out here in the middle of the Atlantic, you had a tower that was 200 feet high. If the power was strong enough, it could pick up that blip. But like I said, you'd fry everything living using that much power from the radar station. No other radar stations in the United States pick up anything in Cuba. It's only the Miami one. Possibly Tampa at the extreme north part, but I don't even think that. Miami's the only one that's there. You can see this with several things too. Hurricanes coming up to Cape Hatteras, North Carolina, which is here. You can see the exact same situation. No other radars picking it up. You get these funny little things, anomalies, because it is only one radar picking up. So another proof, another problem for globe earthers. God bless, guys. Take care.